Based on an idea I had to help my wife with arthritis. The Be-Warm can be fitted on any armchair. It is extremely safe and easy to control. It uses minimal energy, and in fact you can run it for 6 hours for just 1 penny. During the trials we discovered that the energy saving by simply turning the central heating thermostat down a mere 3 Celsius gave us 40% energy saving on our fuel bills.
Distributed energy can help big energy users like businesses and hospitals to take control of their energy by installing wireless sensors and energy efficiency measures, adding technologies like solar panels, large-scale batteries and combined heat and power, or by using their backup generators at periods of high demand. With our Energy Control Centre, distributed energy customers could even earn money by generating energy, reducing their consumption, or delaying their energy use. The result? Lower bills, a more secure energy supply, and a lower carbon footprint.
Whilst taking Baxter round the block, ensure your hair straighteners are off. Or if you slowly start to freeze, turn up your heating a few degrees, 'cause with Hive you control your home from your phone. While you're embarrassing your daughter, you can switch on your hot water. Or perhaps you found a movie frightening. Don't fret, turn on your lighting, 'cause with Hive you control your home from your phone. From your heating to your hot water to your plugs, control your home with Hive.
Because smart meters can accurately measure how much energy you're using and when you're using it, we're now able to offer you flexible time-of-use tariffs. The price of electricity varies throughout the day. When demand is high, the price of electricity is more expensive. But with time-of-use tariffs, we'll give you the opportunity to use cheaper rates when demand is lower, meaning you can make savings. So instead of doing the laundry when lots of people come home from work and turn their lights, microwaves and TVs on, you have the choice to save a few pounds and wait a few hours to do your laundry during an off-peak period. Just shifting the time of 1 load of washing a week can make a difference to your electricity bill.
We have a technology with the potential to transform the energy system. It's beautifully engineered, fully digital, and it comes in a range of colours, and it's incredibly cheap. Realising its potential requires an understanding of human psychology and social practices, but its ubiquity and low cost ensure that energy experts ignore its vital contribution, and economists fail to integrate its value into their cost-benefit analysis, which is why we need to give our energy system the finger.
Hello, I want electricity markets that are free, not prices fixed by businesses. I want the man at number 1 to trade electricity with the lady at number 6 and the family at number 8, as much as they like, whenever they like, and for whatever prices they agree. It's better for the people, it's better for the networks, and it's better for government. It's innovative, it's revolutionary, and it can be done now. Talk to us.
Searching for a better deal on your energy bill is a quick and easy process with CompareTheMarket.com's app Snapped. Here's how it works. Download Snap from the Apple App Store. Hold the camera in front of the QR code on your bill. You'll see code found when it's ready. Check your details are correct and click Get Energy Prices. Scroll through the energy deals and click More Details to start saving in minutes. It's that simple.
Working for a digital industrial company, we solve big problems for customers. Two of the issues with nuclear power are what to do with used nuclear fuel and plutonium. Prism offers a small modular reactor that can be easily built and deployed in the United Kingdom that could disposition the plutonium at Sellafield. In fact, it would supply over 14% of UK's energy needs in the future.
We are moving towards an energy future where renewables will power our homes and businesses. We're only going to be able to make the most of this if we can use the energy when it's available, storage technologies, to make it easy for customers to use energy when it makes the most sense to do so. That way, we will have energy that really is cheaper, greener, and more secure for future generations.
As part of my research at Cambridge, I'm investigating solar cell technologies that use new material classes like organic photovoltaics. These allow for printable solar panels, a manufacturing process that is significantly cheaper. Additionally, they can be light, flexible, and transparent, which opens up new ways in which they could be used, like covering the outsides of buildings. These technologies could disrupt the current energy market by making solar energy price competitive and more widely.
Blockchain, the technology behind Bitcoin, can establish trust and make small transactions at lower cost, bringing wholesale, balancing and capacity markets closer to real time and closer to consumers. A revolution in consumer engagement can increase liquidity and better integrate small generators and storage into the grid. Active load balancing at building, microgrid and city level will make more efficient use of the energy system using the blockchain as the underlying infrastructure.
Hello, my name is William Sandall and I'm one of KiWi's innovation technologists. KiWi Power is a demand response company helping National Grid to balance the UK's electricity network. We've recently installed a state-of-the-art 20 kWh lithium-ion battery as a technical proof of concept. Not only does it function as an uninterruptible power supply, but it could provide ancillary services such as demand response. So how does an office combine demand-side response technology with an on-site battery? First, we've integrated the battery with our free wireless smart metering hardware, which we call the PIP. It enables us to monitor, control and dispatch the battery at a click of a button. Then, we're able to purchase and store electricity from the grid when the price is cheapest. And now it provides backup power for our entire office and critical control centre systems for up to 4 hours, or we can export power back to the grid to aid national management of intermittent renewable sources such as wind or solar. These features can all contribute to creating a smarter and greener energy grid. We're now working with businesses to commercialise grid scale and behind the customer meter battery solutions so that they can earn revenue while supporting the grid during times of peak demand.
Hi, my name is Mircea and I'm a product manager at KiWi Power. KiWi Power is an energy demand response business helping National Grid balance the electricity network. We won a competition for funding from the Mayor of London to introduce the concept of demand response, which we do for large commercial and industrial customers to London households. To do this, we decided to create a residential demand app that connects to household electricity meters and allows users to monitor and better understand their consumption. The app integrates consumption information with demand response servers here at our operational center and notifies individuals via email and in-app notifications when National Grid has a peak demand and a demand response event is triggered. Householders then choose if they want to participate by turning their appliances down or off. returning energy to the grid in a green and cost-effective way. So, they save money on their bills, get paid for participating, and contribute to a greener, more sustainable electricity network. The app predicts earnings for participation, so householders can decide if they want to take part. We've also introduced the league table element, so householders can compete to see how they compare with other participants. We're currently testing this across selected households and hope to roll it out to a wider audience for testing soon.
Cement is the most used material in the world, but unfortunately, its production is associated with CO2 emissions and huge energy consumption. In my research, I have been looking at the development of a self-healing concrete capable of repairing itself without external intervention. This would allow us to produce longer-lasting and more resilient structures, which means significant savings in energy and maintenance costs.
Fusion has the greatest potential to revolutionise energy markets because it would produce abundant baseload power with no CO2 emissions and minimal environmental impact. But we need it soon. Two innovations, spherical tokamaks and high-temperature superconductors, open up the possibility of building smaller fusion machines. They could revolutionise energy markets by delivering fusion smaller, cheaper and faster.
You know, if you think about lighting, the most efficient lighting solution you could possibly have is the one that never turns the lights on at all. So no lights on, no energy being consumed, everybody's very happy. Nah, not really, because we all have to operate in the built environment. So we're really left with two choices, 100% on or 100% off. No, we need to be somewhere in between. And smart, efficient lighting is about finding that optimum point that we run the lights at the minimum energy consumption, but for maximum output. Smart lighting control already has the capacity to deliver demand-side management for building controls, allowing buildings to vary their energy consumption according to the needs of the national grid and its ability to supply the power at any given time. Sometimes the greatest steps forward in innovation are not about a single event. They're about the incremental gains in many, many areas. And smart lighting, enabling you to access real-time data and information about every single light fixture and compare that with the space usage, enables you to hunt for those incremental gains to gain maximum efficiency from your lighting solution. Smart lighting control leverages the benefits of technology convergence. And that technology convergence, much like this example of technology convergence, means you have less installed equipment consuming power in order to deliver the very savings and benefits to the environment that the end user requires. Smart lighting control solutions are great solutions for demand-side management. In the UK, it's facing a real issue about generating enough power for all of us to be able to have 100% access to that power 100% of the time. It's a big challenge for the government. Smart lighting solutions are enabling that possibility to continue for some considerable time until our power generation issues are addressed.
We see energy storage as the technology most capable for constructive disruption. It excites us as it can support the shift to a more decentralised, secure, flexible and low-carbon energy system. There are a wide range of storage technologies that have been developed, and many of those technologies have advanced so fast that policy now is the greatest barrier. government should amend policy to allow storage such as lithium-ion, flow, compressed air, liquid air, pumped hydro and flywheels to compete.
More load and more generation at least cost. This involves novel technologies and also customer side participation that together will lead to a more actively managed network, and therefore the need for a distribution system operator to balance that energy system, and technologies such as storage to help the demand follow the generation.
This is subsea video of a deployed tidal turbine in operation. Nova Innovation has been working hard to produce predictable power, clean, sustainable energy captured from the natural ebb and flow of the tide. A resource which can be predicted minutes, hours, days, weeks, months in advance, even years and decades. Tidal's potential gets even better. Adding energy storage flattens out the rise and fall of the tidal profile, creating a predictable, flat-line, base load power output, as demonstrated by the red dotted line. Our vision is to utilise this abundant resource, improving security of supply, eradicating carbon emissions, and ultimately delivering low-cost, predictable power.
The other day I was at a conference and I was lucky enough to see a talk by the CEO of a company called Zipcar, a lady called Robin Chase. Now Zipcar is a car sharing company. And what she explained is the answer to the world's problems is to create internet-driven companies that can exploit excess capacity in existing systems. If you can do that, you can grow scale very cheaply and very efficiently. Now her example was the company called Airbnb. For those of you who don't know Airbnb is a company that enables you to sort of rent out a room that you're not using or rent out your flat or your house when you're not there. It's a pretty fun way to travel. If you haven't used it, I recommend it. It's far cheaper than a hotel and a lot more exciting way to travel. Now, what this is actually looking to do is exploit the wasted assets, which is your house or your homes. There is an economic value to the room you're not using, or there is an economic value to your whole house when you're not there. What they're able to do is create a very slick platform that enables people to advertise this for periods of the time when they're not there, give you some sense of security that people aren't going to steal stuff through insurance mechanisms, and they've been able to build the biggest hotel chain in the world in over 4 years, surpassing the Intercontinental Hotel. And they have been able to do this because they haven't had to construct a single thing. They are making use out of excess infrastructure that exists in the system. Now, you might think, what has this got to do with demand response? Now, demand response is trying to do the exact same thing by looking to exploit tiny kilowatts of consumption and capacity in your existing assets, be it the BMS system in this building and the HVAC assets, be it commercial refrigeration assets, be it water pumping. There is flexibility in lots of different assets in different proportions. And what we're trying to do is make use of very small bits of these excess capacity in your new assets to build up a virtual power station. And you can do that very cheaply because these assets have already been bought for the purposes of your businesses. And you can do this without ever affecting your processes because the Internet of Things has enabled us to unlock these small amounts of stored energy that was previously unknown.
Energy markets in the UK are already changing quite fast. Emissions are falling, our energy demand is falling, we're seeing more renewables and some new business models coming on the scene. It's hard to find one innovation that's going to revolutionise everything and meet our policy goals, but if I was going to see one thing, it would be what's going to change us from a 20th to a 21st century system, and that's the role of information and communication technologies. These can help to unlock the demand side of the energy system, bring in new business models, and with storage help to change our system completely. But the key point is that none of this is going to happen from innovation alone. It needs public policy support and regulatory change to create new markets for such innovation to thrive.
The key innovation we need for our future energy system to be low carbon, secure and affordable is flexibility. We need to get this flexibility through technical innovations in energy storage, demand-side response, interconnectors and flexible generator connections. That's the flexibility, that's the innovation we need.
Hello, this is about grid-scale energy storage. Batteries are the wrong way to do it, they're too expensive. If I take 4 kilograms of gravel and heat it up to 600 degrees C, I store more electricity in that gravel than you can get into 1 kilogram of the best lithium-ion battery. The marginal cost of the gravel-based system could be 1,000th of the cost of the lithium-ion battery if I integrate it correctly with generation that's based on wind or solar or tidal or waves. This is possible, it needs no new science, only engineering and some support.
Smart meters are paving the way to a smarter, more energy-efficient future. Imagine being rewarded with cheaper tariffs at off-peak times, needing fewer power stations, and being less reliant on importing energy from other countries. Whatever the future, smart meters will transform the way we all buy and use energy, allowing us to manage the grid in a more efficient manner and making us a greener, more energy-efficient nation.
Superconductors have some quantum properties which let them conduct electricity with 100% efficiency. And that is revolutionary because energy efficiency is a big problem in the current landscape. The problem with superconductors is that currently they only work at very low temperatures. So we study these materials and we try to find room temperature superconductors, which could be then in anything from your phone to long distance power lines.
Due to a combination of favourable quantum properties involving a high density of states and particular phononic activity, hydrogenic materials could provide us with superconductivity at room temperature. This paves the way for us to set up a whole grid of solar cells in sub-Saharan Africa and transfer that energy all the way around the world with theoretically zero energy loss. That's why I think the committee should consider research into room temperature superconductivity.
My research is based on supercapacitors. Supercapacitors are energy storage devices like batteries, but they have the potential for replacing conventional batteries because they could be recharged in seconds, would last almost indefinitely and safe. But currently their capacity for storing energy is limited. So I'm trying to improve the amount of energy that could be stored in supercapacitors so one day they can replace the conventional batteries.
At UK Power Networks, we think energy storage is going to revolutionize the electricity system for 3 reasons. First, as we connect more renewable energy onto the network, Storage will enable us to store electricity once it's generated and dispatch it when consumers actually need it. Secondly, storage responds extremely fast. As we connect more electric vehicles and PV rooftops, storage becomes a great solution to help us manage the networks. And finally, storage will empower consumers once it becomes available at a smaller scale. By owning and operating storage, we can keep costs down, avoid network reinforcement, and continue to enable the low-carbon transition.
Hi, my name is Chris, and I want to tell you about a new product we've been working on to change how homes are powered. It's called the SteelGen. There's a prototype behind me. And essentially it's a little power station that sits inside a house, connects to a gas grid just like a boiler, but it produces about 80% of the electricity that your house needs. Not when the sun shines, not when the wind blows, but when you need it. And it does that more efficiently than the grid, and any waste heat gets recovered into your hot water system. So that puts you in control of your energy. It saves about £1,000 a year off your energy bills, and it knocks about a third off your household carbon. And we think that's pretty exciting.
There's more emphasis on going green than ever before. But green usually comes with a price tag and the promise of savings down the line. Wouldn't it be great if someone actually paid you to go green? We do. We're KiWi Power, and we're changing the way UK businesses consume energy during times of peak demand. These peaks occur during extremely hot or cold weather, some sporting events, and other times that unusually high demands are placed on the national grid. When a peak in demand occurs, the national grid turns on older, inefficient power stations to meet the increased demand. The dirty energy from these stations is expensive and significantly more carbon intensive than regular stations. Wouldn't it be great if we could reduce or even eliminate the need for this dirty energy? We can. KiWi Power has a solution. It's called Energy Demand Management, and our growing network of participating businesses is helping to eliminate the UK's reliance on inefficient power stations. How does it work? When electricity demand begins to peak, we call on our network of participants to temporarily switch off or reduce non-critical systems, such as heating, cooling and lighting, or turn on standby generators for short periods of time until the demand returns to normal levels. We monitor our participants using smart meters, which track energy consumption in real time. This allows the national grid to turn off the older, inefficient power stations, greatly reducing the cost of energy and the impact on the environment. And energy demand management increases grid reliability, smoothing out supply from renewable energy sources connected to the grid. So on cloudy or less windy days, grid demand can be balanced to meet the intermittent renewable supply. So what's the downside? Nothing. No impact on your operations, no cost to your business. KiWi Power's costs are recovered from the national grid. And best of all, the national grid pays you to participate, as it is cheaper than using older power stations. The only question left is, how do I sign up? Visit www.kiwipower.com today to learn more and sign up for a no-obligation assessment. With your help, KiWi Power can continue making electricity cleaner and cheaper, one success story at a time.